Hello, lazy students. Today we're going to look at describing graphs. What you're going to want to have on you today, you're going to want your notes, a pencil, and then that foldable I handed out to you in class. Your learning targets. I can determine where local maximums and minimums are on a graph. I can determine where a graph is increasing or decreasing and state the intervals. And I can find the x-intercepts and y-intercepts of a graph. So basically, what are we doing? Well, we're going to basically look at a graph and be able to point out where intercepts are, where is it going up, where is it going down, when do I have a max, when do I have a min, that kind of stuff. So you're going to need to have this foldable out, and you're going to want to fold where I have green lines and cut where I have red. So go ahead and quickly do that. So you're going to want to pause the video. So you're going to fold and cut where you have red. So how are we going to start filling this out? Well, first part, we're going to open the first top left flap, and that is the x-intercept is the point where the graph crosses the x-axis. So in the middle, we actually have three places where our graph crosses the x-axis. One being -3, 0, another one being 1, 0, and another one being 5, 0. You might want to have different colors out, so then you can kind of color code based on what the x-intercept, so the x-intercept where you wrote here should be the same color as the dots that you're going to put there, okay? That way it's kind of color coded, so when you look at this back later, you actually know what we're doing. The second part, the y-intercept, is the point where the graph crosses the y-axis. So we need to look and see, where does my graph cross the y-axis? Well, it crosses right there at 0, 2. So that is my y-intercept because it crosses the y-axis. Now, here comes a little bit of a difficult part. Increasing and decreasing. So a function is increasing on an interval if the y value increases as the x value increases. So basically, it looks like the function's going up. So right here would be one part of I'm increasing, and we need to write that as an interval. So to write increasing and decreasing intervals, I need to think here. So you're always going to want to do your x values. So I'm going to want to draw in right here. That's where it hits, right? But this goes on forever. So we're looking at our x's, right? So I know it's starting at -infinity. And we stop increasing right here. Now, you're going to be tempted to put 4 because that's the y. But you're not using the y's. You're going to use the x's with your intervals. So my function stops increasing on its domain at -1. Now, we're including -1 because it stops there. There are some disagreements. You can also put a comma or a parenthesis at -1. Both of them are acceptable. We're going to use a bracket in this class. Where else am I increasing? Well, it looks like I'm increasing right there, right? My function starts looking like it's going upwards. So I'm going to draw my line here so I can see my x value, not the y. So it looks like it starts increasing at 3 on my domain, right? Now, I need to be able to say this and this. So to be able to say this and, using the and, you're going to use what's known as a union. Union basically means this and this. So basically it's a special way in math to basically say and. Okay, so I need to start at 3, and it looks like I'm going on forever. So I'm actually going to go on for +infinity. That is all I'm increasing. But now, what about decreasing? So a function's decreasing on an interval if the y value decreases as the x value increases. Basically, it looks like the slope of the line is going downwards. So basically from right there to right there is my decreasing interval. So I'm going to write up here, decreasing. So I am decreasing from here to here on my domain. So I am decreasing from -1 to 3. Now, never put from 4 to -4. That's on your range. We want to know where in my domain am I decreasing. Now, if someone would ask where in the range are you decreasing, then you would be able to say that. But you're always going to be looking at your x's. So where in my domain am I decreasing? What about the next ones? Well, the maximum is the y value of the highest point in the particular region of a graph. So my max on this particular one would be the hill that I have right there. So my max on this graph is not the -1 because it's the y value, right? So my max would be at 4. So my maximum is y equals 4. Okay? My minimum is the y value of the lowest point in the particular region of a graph. So notice I have a minimum at 3, -4. But now I only want the y value, so not the 3, but the -4. So my minimum is y equals -4. Not too bad, right? Now, there's other ways for me to say intercepts. You might hear me call them zeros further as we continue in our studies. You might hear me call them roots. You've heard me call them solutions when we were doing systems, and then intercepts. So if I say roots, intercepts, zeros, any of that nature, those are all meaning your intercepts of some of your x-intercepts. So let's do a couple of examples here. So my x-intercepts are going to be ordered pairs. So where do I cross the x-axis? Well, it looks like I'm crossing here, 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 and here. So I'm crossing at -4, 0. So I'm going to make sure I write that as my ordered pair, comma, -3, 0. Let's call that 0.5. And 3, 0. Okay. Now, am I crossing the y-axis at all for my y-intercept? It definitely looks like it. It looks like I'm crossing the y-axis right here at 0, -2. Like that. Now, where am I increasing? So I'm just going to highlight here. Where am I increasing my graph? Well, it looks like my graph is increasing right here until right there, right? And then it looks like I'm also increasing from there to there. Looks like my graph's going up. So what I'm going to do now is I'm going to draw in a line really quick for where it starts that, where I stop increasing. And then I stop increasing right there, it looks like. There we go. So, it looks like I start at -infinity, right? Because I'm on the negative side of the x's, so my -infinity. So I'm starting at -infinity, and I'm going until I hit right about there, -3.5, -3.75, something like that. Oh, bracket. Make sure I bracket that. There we go. Now, it looks like I start increasing again right here, right? There. So that's at -1.5 roughly. So I'm going to put a U for my and. So that's -1.5 until... looks like it's at 2. Done with my increasing. So now decreasing, if my function's not increasing, it's got to be decreasing. So basically I'm cutting up my domain into increasing intervals and decreasing intervals. So anything that's not increasing, I got to put under decreasing. So from here to here, I need that decreasing. So I said that was -3.75 right here, right? So I know that I'm starting at -3.75, and I'm going until, what was that x value? -1.75, right? Or 1.5. So I'm going from -3.75 to -1.5. That's one of my intervals, and it looks like I have another one. So I have from here until forever, right? And forever in the positive x direction. Because remember, we're talking domain. So, whoops, I'm starting at 2, because we ended at 2, right? So I gotta start at 2 to infinity. What about the max? Do I have some maximums? It looks like I do. I have one right here and one right there. Y equals, so where I got max there and a max there. So if I go over here, I'm at y equals 1, right? And what's my other one? At y equals 5. So that's my two maximums, my two hills. Basically, I always ask myself, where are my hills on my graph? Now, what about my minimums? Well, it looks like I have a minimum right here. So lowest point of the valley. It's my lowest valley that I have, that I can see. Oop, there should be an E in valley. There we go. Go all the way over. It looks like I'm at negative 5.5, right? There we go. Now, what about our domain? Well, it looks like our domain goes from negative infinity to infinity, right? We're covering all the negative x values because this is going to keep opening up. And I'm going to cover all the positive x values. So I'm going from negative infinity to infinity. What about range? Well, I'm covering all the negative y's, right? But I'm not covering all the positive y's. I'm stopping right here. This is the highest point on my graph, right? So my highest point is at 5. So I'm going to say I start at negative y's and I make it all the way up to 5. But no more than 5. Let's try one more problem. So our intercepts. Well, my x-intercepts got one right there and one right there. So I got a negative 1, 0 and 3, 0. What about my y-intercept? Well, I got one right here at 0, negative 3, it looks like. Perfect. What about increasing and decreasing? Well, let's take my highlighter here. So it looks like I'm decreasing right here, right? My graph is going downwards. And I stop going downwards right there. So I then looks like I'm increasing from here to there, right? So let me write here with our increasing. So we're increasing from, so it looks like it's splitting right at 1, right? So I'm increasing from 1 to infinity, and I'm decreasing from negative infinity to the x value of my point right here at the bottom, 1. There we go. Now, do I have a maximum on this graph? No, it doesn't look like it, right? I only got a valley. So, not applicable or none or something like that, right? Something that says, nope, sorry, Marsh, we don't got that. What about minimum? Well, it looks like I have a valley here. And the y on my minimum is at negative 4. So my minimum is y equals negative 4. What about our domain? Well, it looks like this is going to keep opening up and up and up and up and up. Can't close it because that's an arrow right there. Can't close this side, there's an arrow. So my domain is from negative infinity to infinity. What about range? Well, my lowest y value on my graph, the lowest my graph can go, is at negative 4. So I'm going to start at negative 4. But then it keeps going up and up and up, right? Because I have arrows. So from negative infinity to, or negative 4 to infinity would be my range. And that's the end of this video. See you later, Sabers.